Okay, well, I guess it would not be too appropriate for me to thank the organizers for inviting me to give this paper, since I am one of the co-organizers. So, but let me thank the Central Bank of Chile for asking me to organize this event, which I'm enjoying very much. Very good. So this is joint work with Luca Gambetti, who is here, who had has discussed the paper already this morning, and it's on the behavior of the wage Phillips curve. So let's see if I know how to do this.
Avanza, retrocede y punto de láser.
Okay, thank you. So, I mean, in front of this audience, and given all these papers that we've seen today, this paper doesn't need much motivation. The US economy and other advanced economies face what is known as the twin puzzle, and the twin puzzle refers to the fact that, you know, despite this very large adjustment of the unemployment rate upward and downward during the Great Recession and in its aftermath, inflation measures haven't really responded much. Okay? Even though this has been the largest adjustment in the unemployment rate that the U.S. economy has experienced in the post-war period. So there was missing deflation during the recession and missing inflation during the recovery. Now, of course, this is important for central banks because a flatter Phillips curve, which is what that evidence seems to suggest, implies that if there are deviations of inflation from an inflation target, there may be a need for more extreme policies to be implemented. The sacrifice ratio associated with any permanent change in inflation will be larger. And more generally, I think it poses a challenge to inflation targeting frameworks, because those frameworks rely very much on the idea that there is some connection between the level of economic slack and inflation, because central banks cannot influence inflation directly. They do so by influencing the level of economic slack. So through changes in interest rates and other measures. So if inflation becomes decoupled from economic activity, it's hard to see how a central bank could have any influence on inflation, and hence the whole inflation targeting framework will be called into question. Now, in this paper, we focus on a particular dimension of the relationship between inflation and economic activity, which is the wage Phillips curve. Okay, so on the connection between wage inflation and the unemployment rate. And many people think that the behavior of wage inflation during the recent episode is at the heart of this disconnect between price inflation and measures of economic activity. Now, the paper has two parts. First, we document the changes over time in the wage Phillips curve. Okay, so so it will be just some reduced form evidence based on OLS regressions and using a very simple specification of the wage Phillips curve. Then I will point to some shortcomings of that approach. And in the second part of the paper, we propose a methodology, if you want, to overcome those shortcomings, and that's what we call semi-structural evidence. So the idea here is to use to decompose the measures of inflation and unemployment into different components, and to use and to estimate what we call a conditional Phillips curve, using as data just specific components of inflation and unemployment. Okay, so you'll see later how that works. Now, again, so here are just some recent papers that have documented these changes in the Phillips curve here, and are the main differences in our approach have to do with the focus on wage inflation and the semi-structural approach that I had mentioned earlier. Okay, so let me start by showing you a scatter plot of wage inflation and the unemployment rate. Okay, so again, and this is for the post-war period. The measure of inflation is average hourly earnings for production and non-supervisory workers. And if you look just at the observations here, these quarterly data, I mean, I guess one should call this the Phillips circle more than the Phillips curve. But sorry, the green dots, those correspond to a particular period, which is somewhat special. It's the Great Inflation period and the subsequent disinflation associated with Volcker's chairmanship. So those are that's a period in which the mean inflation changed a lot, and hence that may have, if wage inflation to some extent depends not only on the unemployment rate or some measure of economic slack, but also on price inflation, that is a reason why the Phillips curve may have shifted. Now for the remaining periods, okay, that includes part of the 60s, the data starts in 64 here, the Great Moderation and the Crisis and Recovery, well, there's something, it has more of a shape of a curve. And here is where we see, that if you look at the red dots, that those correspond to the Crisis and Recovery. So we see that the relationship seems to have become somewhat flatter. Okay, so that's consistent with this view that the Phillips curve has flattened. Okay, but this is just an unconditional. This gives us an idea of why the unconditional correlation may have weakened. But of course, we're not controlling for other variables like inflation. And for shocks that may have shifted that Phillips curve. Okay, so here's the specification that we're going to focus on. Okay, so we have this is wage inflation, quarterly wage inflation. This is a measure of lagged price inflation, and the idea is to think of whatever measure of lagged price inflation is relevant for wage indexation purposes, or that workers, care about when they, to the extent that they index partly wage inflation to price inflation. Gamma here one can interpret as being related to the degree of price indexation, and here we have the unemployment rate, and this is a shock, okay, or some error term. Now, there is an equation like this can be given some micro foundations, and I think it's useful in order to interpret, for instance, the nature of the error term. Okay, so very quickly here, this is based on some work of mine, but which relies on a standard specification of wage setting. So it's a model of Calvo wage setting with partial indexation that is embedded in, I would say, the vast majority of DSG models that are being used at central banks around the world. It's originally due to Erzek, Henderson, and Levin. Okay, so that model of wage setting implies an equation for wage inflation that looks like this. Okay, so here we have wage inflation, expected wage inflation, and this is the deviation of the average wage markup from the natural wage markup, where the natural wage markup is the markup that we would observe if wages were fully flexible. Okay. Now, this is not, strictly speaking, wage inflation. This is that's the reason for the tilde here. It's the gap between wage inflation and some weighted average of steady-state price inflation and lagged price inflation. Okay, so and again, this captures this automatic wage indexation that is assumed in the model. So even though nominal wages are sticky, individual wages are sticky and are adjusted only infrequently, those workers who do not re-optimize their wages see their wages mechanically adjusted according to some measure, according to this variable here, this weighted average of steady state inflation and lagged price inflation. Okay? Now, if you assume that this wage markup gap follows an AR1 process, and this is true under certain assumptions. This will be true in equilibrium under certain assumptions about the driving forces of the economy and so on. One can solve this equation forward and obtain an expression like this. Okay? It relates this measure of, let me call it modified wage inflation, to the wage markup gap. Okay? So that's the first step. The second step, one can derive, and this is what is based on my own work, earlier work, one can show that this wage markup is proportional to the gap between, this is the log of the labor supply, and this is the log of employment. And that gap can be interpreted, it doesn't exactly correspond to the standard measures of unemployment rate, but it's something that is very close to it, okay? So now, you can plug this into here, you can combine the two and rearrange terms, and you get a wage inflation equation that looks like this. And this, as you can see, takes exactly the same form as that simple equation that I showed you earlier that we're going to estimate. This gamma is the extent to which now has an interpretation. It's the extent to which wage inflation is indexed to lagged price inflation. The coefficient on the unemployment rate has also a structural interpretation. It is related, among other things, to the degree of wage stickiness, which affects this coefficient here. And most importantly, for our purposes, the error term in this equation, okay, has an interpretation. It's related to fluctuations in this natural wage markup, or which we typically view as exogenous. Okay. Very good. So that's, again, just an attempt to provide some micro foundations to this. So these are the data that we're going to use. So we'll, as I said, average hourly earnings of production and non-supervisory workers as a measure of wages, the GDP deflator as a measure of inflation, and the civilian unemployment rate. And we look at two sample periods, the pre-crisis period and the crisis and recovery period. But we will focus, for reasons that will become clear, we will also show some results for the Great Moderation period, what we call the Great Moderation period, okay, which is just a subset, or which is contained in the pre-crisis period. Okay, so what I'll do next is just to show you this. I'll show you several tables. They all have the same structure, and they report the estimates of that simple. The OLS estimates of that simple equation. Okay, so again, here you have the coefficient on lagged inflation on the unemployment rate, and here you have the different sample periods and the p-values for tests of equality of coefficients between periods. So things to observe. First, one, I will show you, as I said, several tables that are using alternative data or alternative specifications. And there's one feature that shows very clearly on every table, okay, which is the coefficient on price inflation, okay, declines over time and essentially becomes insignificant, okay? And the other feature that will also be very robust and will show on every table is that, the coefficient on the unemployment rate, which is significant and negative, as we would expect. Okay, this is for the full pre-crisis period. Okay, it seems to increase in absolute value during the Great Moderation period. Okay, that's something that, as far as I know, had not been pointed to by before, had not been observed before. And then it declines dramatically in the crisis and recovery period. Okay, so that there is no monotonic decline in that coefficient, but it seems to increase first and then decline in absolute value. It's still significant at the end of the sample period. Okay. Now, okay, so this is based on rolling regressions. This is the unemployment coefficient, and it captures essentially what I said. It was low in the early part of the sample, and it became more negative, larger in absolute value, more negative during the great moderation period, and then it shrinks during the crisis and the recovery period. Okay. This is the coefficient on lagged inflation, and again, you can see that in the recent period is essentially it's insignificantly different from 0. Now, okay, so this is a table that has exactly the same structure as before, but now instead of the GDP deflator as a measure of price inflation, we use CPI. Okay, but again, the results are identical, at least qualitatively. Here, we use lagged unemployment rate as opposed to a contemporaneous unemployment rate. The results do not change. Okay. Here, we use, in the previous tables, we were using lagged quarterly price inflation on the right-hand side. Here, we use lagged year-on-year, so the average of 4 previous quarters, inflation on the right-hand side. And again, not the two key findings that I had stressed survive. Okay, so those findings seem to be pretty robust. Now, what are the main shortcomings of this kind of evidence? Okay. Well, first, I mean, the specification of the wage inflation equation, may be viewed as ad hoc, and I've given you some micro foundations and so on, but you may not be completely convinced by those. It's unlikely to be, the coefficients are unlikely to be deeply structural. That is, they may not be invariant to regime shifts. And the one that we are going to stress here is that the error term in that equation is likely to be correlated with the regressors. Okay, and this correlation emerges very naturally if one gives the structural interpretation that I've given you earlier, because that error term is not measurement error or something that cannot have a simple economic interpretation, but has the economic interpretation of wage markup shocks. Okay, and wage markup shocks, when embedded in any standard DIGE model, generate responses in inflation, in price inflation, in wage inflation, in the unemployment rate, and so on. So that would imply that the OLS estimates of the coefficients in that equation would be biased. Now, there is work by Smets and Wouters and another paper of Smets and Wouters with myself showing that those wage markup shocks are non-negligible sources of fluctuations. Okay, they are not something that we can ignore because they are tiny, but they seem to be non-negligible sources of fluctuations in both quantities and prices. And in particular, they have significant effects on unemployment and inflation. And that's what would generate this bias in all OLS estimates. But not only that, the relative importance of these wage markup shocks may have changed over time. Okay? And those changes over time in the volatility or the variance of these wage markup shocks would lead to change in the estimated coefficients when using OLS. Okay, so they may give the impression, okay, of a structural change over time when, in truth, the only thing that is happening is that the volatility of wage markup shocks may have changed over time. Okay, very good. So we're going to try to overcome that limitation. So what we do is the following. So we estimate the component of fluctuations in wage inflation, price inflation, and the unemployment rate that is orthogonal to wage markup shocks. Okay, and using a framework that allows for these structural changes over time. We need to, in order to be consistent with the hypothesis that there may have been structural changes over time, we need to use an empirical framework that allows for those changes over time, okay, in order to obtain this decomposition. Okay, so the idea is, well, if X is a vector of variables that includes wage inflation, price inflation, and the unemployment rate, we can decompose that vector into two components. This is the component that is associated with wage markup shocks. This would be the wage markup shocks. And this is the component that is associated with all other shocks in the economy. Okay? And so what we're going to do is to try to, to uncover this component of all variables, and then re-estimate. We're going to re-estimate the wage Phillips curve using this component, okay? Which by construction will be orthogonal to wage markup shocks, okay? And this is what we call the conditional wage Phillips curve, okay? And in addition, we are going, since that still relies on a particular specification of the wage Phillips curve, which you may not be happy with, we're going to provide other measures of the changing relationship between unemployment and wage inflation that, again, that are conditional on specific shocks other than the wage markup shock, and that do not rely on a specific equation. And this is related to the dynamic multipliers that Matteo showed us this morning. It's essentially the same idea. Okay, so here's our empirical model very quickly, and without getting into the details. It's a structural VAR model that allows for changes over time in all the coefficients. Okay, so this would be the reduced VAR. Okay, so it takes this form of a standard reduced form VAR. This would be the innovations in the variables in X. What does X contain? It contains the first difference of the log of labor productivity, wage inflation, price inflation, the unemployment rate, and the long-term interest rate. And we use the long-term interest rate and not the short-term interest rate because our sample period contains the period in which the zero lower bound is binding, and we don't want to have any trouble in that regard. So we use the 10-year government bond yield, which never hit the zero lower bound. Okay? So the difference with the standard model is that all these matrices, you see, have a T subscript. That means that they are allowed to change over time. Okay? Now, this sigma is the variance-covariance matrix of the innovations, which is also allowed to change over time. And finally, the mapping, in these structural VARs, it is typically assumed that there is a linear mapping between the reduced form innovations and the contemporaneous structural shocks. Okay, and that's what it's assumed here. We also make that assumption, but that linear mapping is also allowed to change over time. That's why it has this T. Epsilon here is the vector of structural shocks. Okay? So we carry out the estimation as in work by Del Negro and Primiceri. Okay, there's nothing novel in terms of the particular way we estimate this. And the outcome of this is what is ultimately this, what we call the structural local time-varying coefficients moving average representation, okay, which relates each variable in xt to the current and lagged values of each of the structural shocks. Okay, so now what we need to do in order to estimate this CT of L. Okay, this contains all just the impulse responses to all the shocks, but with a time subscript, so we have an impulse response for each period, is to impose a number of identifying restrictions that allows us to recover this matrix QT. Okay, and what are those restrictions? So these are the restrictions that we use that we are largely informed by the properties of standard DSG models. Okay, and we think should be largely uncontroversial. The first one is based on some earlier work of mine that assumes that technology shocks are the only shocks that can have a permanent effect on the level of labor productivity. So that's a long-run restriction that we impose. And the rest are sign restrictions. And what are those sign restrictions? What we call demand shocks, which should be interpreted as non-monetary demand shocks, are shocks that are the only shocks that generate first, that do not have a permanent effect on labor productivity and so on, but that's common to all shocks other than technology. But they are the only shocks that generate a positive co-movement between output, price inflation, and the long-term interest rate. The idea being here that the central bank, here the Fed, responds by increasing interest rates whenever output and inflation increase. And they do so, the central bank does so in a persistent way, so that it is reflected in the long-term rate. Now, monetary policy shocks generate a positive co-movement between output and price inflation, but a negative co-movement with the long-term interest rate, okay? Because here it's the change in the interest rate that is driving the change in output and inflation in the opposite direction. Then we have price markup shocks, which are the shocks that generate a positive co-movement between, are the only shocks that generate a positive co-movement between price inflation and the price markup, where the price markup is a linear combination of some of the variables that enter vector x. It's the gap between labor productivity and the real wage, or if you want, is the price level minus marginal cost, okay? And wage markup shocks are the only shocks that generate a positive co-movement between between wage inflation and the unemployment rate. Okay, and again, that's a property that holds in these medium scale new Keynesian models. Okay, very good. So again, using these restrictions, we estimate the different components of the different variables in X, and now we remove the component for each variable. We remove the component associated with wage markup shocks, okay? And the remaining components are orthogonal to that, so we can use them to estimate the wage Phillips curve in a way that is not subject to the biases that we otherwise would have had, okay? And that's what we call the conditional wage Phillips curve, okay? So again, this is the specification using the GDP deflator, quarterly GDP deflator as a lagged quarterly GDP deflator inflation as a measure of price inflation, okay? And the structure is the same as before. So what do we see here? Well, you know, the absolute values of the estimates change, okay? And in ways that are substantial, but the overall picture doesn't change. Okay, so in particular, we see that lagged inflation, lagged price inflation, has a shrinking influence on wage inflation over time. So that's consistent with the evidence that we had obtained with using OLS. The coefficient on the unemployment rate appears to be much larger than estimated with OLS. Okay, but the pattern over time is the same that I had emphasized earlier. Okay, so it increases during the Great Moderation in absolute value, and then it shrinks substantially during the crisis and recovery period. But the value is, when using OLS, this was minus 0.11. Okay, so it's when using this alternative approach, that coefficient is much larger in absolute value, okay? And this is the rolling regressions associated, again, using the non-wage markup component of the variables, and you see, again, this is the unemployment coefficient over time, and you see that, the estimates are somewhat flatter. They don't change so much over time as suggested by the OLS, by using OLS with the raw data, okay, as opposed to with that specific component, okay? This is the coefficient on lagged inflation. The picture is very similar to the one that was based on the raw data, okay? And this again uses alternative specifications here, lagged unemployment, again, same picture. The year-on-year GDP deflator, similar patterns. Okay, so this is actually one which there is a slight difference because this coefficient really doesn't go down to a value close to zero, and it remains significant. That's okay. But the pattern for the unemployment coefficient is the same. Okay. Now, Again, these tables that I showed you were based on this particular specification of the wage inflation equation. Okay? And well, that has a number of limitations, as I said. It may be viewed as kind of ad hoc. And also, we were implicitly assuming that the coefficients, at least within each subsample period, remain constant. Okay? Whereas, our structural VAR approach was allowing for a continuous change in those coefficients. So there was some kind of inconsistency there. Okay? So let's use an approach that imposes less structure. Okay? That only imposes the assumptions implicit in the VAR. Okay? And these are what we call the conditional dynamic multipliers. And again, that's what's similar to what Matteo showed us this morning, but applied to different variables. Here we have the multiplier not between unit labor costs and price inflation, but between the unemployment rate and wage inflation. Okay? So that's how we define the multiplier. So it's a ratio of the cumulative sum of impulse responses. In the numerator, you have the cumulative response of wage inflation to a particular shock, a particular structural shock, and in the denominator, you have the cumulative response of the unemployment rate to the same shock. So it's a ratio of the areas under the impulse response. Now, the nice thing or the nice feature of this is that this multiplier, has a time subscript. Okay, so our framework allows us to estimate this multiplier for each period and to see how that multiplier has changed over time. And of course, it also depends. K here is the horizon. We can compute this multiplier at different. We have to truncate it somehow, no? So we can compute it at different horizons. So what I will show you next, and that will be the last piece of evidence, is the evolution over time of these conditional dynamic multipliers in response to different shocks other than the wage markup shock. In particular, this is in response to monetary policy shocks. Okay, so here you have time, okay, actual time, and for each period, okay, for each historical period, you have the multiplier at different horizons. Okay, we compute the multiplier up to an 8-quarter horizon. Okay, so we can look at how that multiplier has changed at the short horizons or at slightly longer horizons. Okay, and what we see is that the multiplier is negative. Okay, because there is in response to monetary policy shocks, there is a negative, or those shocks generate a negative co-movement between the unemployment rate and wage inflation, as expected. Okay, but you can see that in absolute value, okay, it goes down over time, especially in the short run, but also, okay, even though not so dramatically, at a longer horizon. Okay, so again, this is consistent with the idea of weakening of the relationship between the unemployment rate and wage inflation over time, and it suggests that this has been a very gradual change over time. Okay. Okay, so this contrasts a bit with some of the evidence that we showed earlier. This is the same, but in response to demand shocks, the non-monetary demand shocks. Okay, and again, the picture is very similar. It's a bit more rugged, but you can see that over time, that multiplier declines in absolute value, both in the short run and at longer horizons. When we consider also a price markup shock, and here for a price markup shock, perhaps surprisingly, we don't observe that shrinking in absolute value of this multiplier. And again, we don't have any obvious explanation for that. Okay, but we don't. Essentially, the multiplier remains largely unchanged over time. Okay, so just to conclude, what was the initial question that we had posed? Well, has the U.S. wage Phillips curve flattened over time? And the reduced form evidence suggests that the answer is yes, substantially, but not monotonically. Now, when we look at what we call the semi-structural evidence, okay, using these components of the different variables, the answer remains a positive one, but the changes appear to be less dramatic than implied by the reduced form evidence. And in all cases, what we seem to obtain is this vanishing effect of past price inflation on wage inflation. Okay, so that's all I have to say. Thank you.
In the time.
Okay.